it all began when BK assigned us the Hovercraft for Freshman Engineering Design Day. So we became the Hover Creators. The history of the hovercraft began in 1716 with a Swedish scientist, Emanuel Swedenborg. His ideas were a surface effect vehicle, moderately different than that of the modern hovercraft design. Ideas and inventions traveled over time and overseas, ranging from water effect vehicles to levipads. The modern hovercraft design is by Sir Christopher Cockerell. In 1956, he came up with his first design, involving an empty cat food tin inside of a coffee tin, an industrial air blower, and a pair of kitchen scales. His goal was to create a hovercraft that would move faster over water by floating on a layer of air to reduce friction between the water and the vehicle. We were given one mission, and that was to create a hovercraft for under $40 that could fly on a carpet track 50 foot long by 1.5 foot wide and make turns up to 90 degrees.
So basically our hovercraft is designed to float on a cushion of air that has been forced under the craft by a lift motor. To help the lift, we cut 4 small holes on the bottom of the skirt that is attached to the body frame. The holes are located in the spots that touch the ground when it is inflated to balance the bottom pressure. An air chamber is also designed to trap the air inside the skirt to provide lift force and reduce waste energy. Once lifted, the 2 propellers on the tail of the vehicle will provide thrust needed to push the craft forward. To steer, we apply the double propeller system. If the right propeller is turned off, while the left one stays active, the total force done will help turn the hovercraft to the right, while the opposite action will turn it to the left. All motors are powered by 9-volt batteries and connected to a control board for remote control.
Our hovercraft did not move as we intended at FED and barely made it past the starting line. There were 3 issues as to why our hovercraft was unable to complete the required objective. Firstly, the main lift motor was unable to sustain a consistent amount of pressure, which led to some turbulence after continued use. This is because we were unable to develop an efficient enough system to have airflow exit out the skirt, instead of the lift motor's hole. However, even when the hovercraft was working correctly, we lacked the needed power of our propellers to move our fully loaded hovercraft. To improve our hovercraft in the future, we would have to fix 3 things: the skirt, the hole above the air chamber, and the propulsion system. To fix our skirt, we would redesign it and create a more balanced system of pressure. We would then have to increase the effectiveness of our lift motor, which we would do by concealing more of the open area above the lift propeller. Thirdly, to improve our hovercraft, we would need to find a more powerful propeller because RC car motors are not strong enough to drive our hovercraft.
In the end, it doesn't matter if we lose or win. What matters is that we learned how to analyze our work through root cause analysis. We can spot our mistakes and replace them, and we now can spot our good things that we did and build on them. What matters in the end is what you learn, and we learned something. We never stop working, and we will never stop working. The moment you fail is the moment you stop, and the moment you succeed is the moment you continue to work. And this is what we are going to do to become the engineers of the coming generations. Long live engineering.
Some advice for next year's freshmen and their Engineering Design Day projects. Definitely start earlier than you think, because you will procrastinate no matter how hard you try. Don't be afraid to ask for help. There are many people to help you along the way. Definitely plan more time than you think you will need, and schedule room for setbacks, because there will be many. Definitely communicate well with your teammates, because it is key in any group project. Also, don't forget to have lots of fun.